Look up at the night sky. Between those pinpricks of light, what do you see? Nothing, right? Just empty black space stretching endlessly into the void. But here's the thing that will fundamentally change how you understand our universe. That nothing isn't nothing at all. And more importantly, the scale of that nothingness is so vast, so incomprehensibly large, that it reveals something terrifying and beautiful about our place in existence. Today, we're going on a journey through the empty spaces of our universe. We're going to measure the void, quantify the distances between things, and discover that the space between the stars isn't just big. It's so overwhelmingly enormous that it borders on the philosophical. By the end of this journey, you'll never look at the night sky the same way again. Let's start with something we can understand. Something human. Imagine you're standing in the middle of Times Square in New York City. You're surrounded by people, buildings, noise, light, advertisements screaming for your attention. There's barely any empty space at all. Now let's zoom out. From just a few hundred feet up, Times Square becomes a small intersection. The people disappear. The city spreads out below you, and suddenly there's a lot more emptiness than stuff. Parks, rivers, gaps between buildings keep going higher. At 10,000 feet, New York City is just a gray cluster on the edge of a continent. There's ocean, farmland, mountains, vast stretches of nothing but trees. This realization that the universe is not just dangerous but ultimately fatal to everything we value is perhaps the deepest terror that space can inspire. At 250 miles up, you're at the altitude of the International Space Station. From here, you can see the entire eastern seaboard of the United States in one glance. The cities that seemed so large, they're tiny specks. Most of what you see is emptiness. Ocean, clouds, the dark side of the planet, lit only by the sparse glow of human civilization. But here's what's interesting. Even though you're in outer space, you're not really in the emptiness yet. You're still inside Earth's sphere of influence. The atmosphere hasn't completely disappeared. There are still trace molecules up here, enough that the ISS has to periodically boost its orbit to avoid falling back down. You're still, in a cosmic sense, touching the Earth. To really understand the scale of nothingness, we need to go further. Much further. The Moon sits about 240,000 miles away from Earth. That's about 30 Earth diameters. If Earth were a basketball, the Moon would be a tennis ball sitting about 24 feet away. That might not sound like much. But here's the crucial part between Earth and the Moon. There's nothing. Not just not much, literally nothing of significance. No air, no dust, no particles, no asteroids or space stations or satellites once you get a certain distance out. Just void, pure, uninterrupted emptiness. And this emptiness is so complete that if you screamed as loudly as you possibly could, there would be no sound. Sound needs molecules to travel through. And between Earth and the Moon, there aren't enough molecules to carry it. Now here's where it gets interesting. That gap, that 250,000 miles of absolute nothing, is the smallest meaningful gap in our cosmic neighborhood. It's the closest thing to Earth that isn't Earth, and we've only sent 12 humans across it in all of history. Let that sink in. The tiniest meaningful distance in space, our nearest neighbor, is so vast that only a dozen people have ever crossed it, and it took them 3 days traveling at 25,000 miles per hour to get there. Let's keep going. Venus, our nearest planetary neighbor, is about 25 million miles away at its closest approach. That's 100 times further than the Moon. If you wanted to drive there in a car at highway speeds, it would take you about 500 years of non-stop driving, just to reach our nearest planet. But Venus is right next door, cosmically speaking. Mars, depending on where it is in its orbit, ranges from about 35 million to 250 million miles away. Jupiter, The giant of our solar system sits about 480 million miles from the Sun. Saturn is almost 1 billion miles out. Let me give you a better sense of these distances. The Sun is huge, about 1 million Earths could fit inside it. If the Sun were hollow, you could line up 100 Earths across its diameter. It's so massive that it contains 99.8% of all the mass in our entire solar system. Everything else, all the planets, moons, asteroids, comets, and dust, makes up just 0.2%. Now, if you scaled down the Sun to the size of a golf ball and placed it in New York City, where would the planets be? Mercury would be about 12 feet away, across a room. Venus would be about 22 feet away. Earth would be 30 feet away, still in the same large room, or just outside. Mars would be about 45 feet away, roughly across a street. But the gas giants? Jupiter would be 1/4 mile away. Saturn would be nearly 1/2 mile away. Uranus would be a full mile away. And Neptune, the outermost planet, would be about 1.6 miles away from your golf ball's sun. Think about that. If the Sun were a golf ball, our solar system would stretch nearly 2 miles in every direction. And in all that space, you'd find 8 planets and their moons, a handful of dwarf planets, some asteroids, and countless small rocks and ice chunks. That's it. Everything else, more than 99% of the volume, is emptiness. Here's something that might surprise you: the asteroid belt, that famous ring of rocks between Mars and Jupiter that looks so dense and dangerous in science fiction movies. It's almost entirely empty space. The asteroid belt contains millions of asteroids, ranging from tiny pebbles to Ceres, a dwarf planet 600 miles across. But if you were to actually fly through the asteroid belt, you likely wouldn't see a single asteroid. The average distance between asteroids is about 600,000 miles. That's more than twice the distance from Earth to the Moon. If you stood on one asteroid, the nearest other asteroid would be a tiny, barely visible speck in the sky, if you could see it at all. Space probes have flown through the asteroid belt dozens of times, and not once has there been any danger of collision. The rocks are just too far apart. The dense asteroid belt is actually nearly perfect vacuum, with occasional tiny specks of matter. Beyond Neptune, things get even more empty. There's the Kuiper Belt, a region of icy objects that includes Pluto. It extends from about 30 astronomical units. From the Sun, 1 AU is the distance from Earth to the Sun, about 93 million miles to about 50 AU. That's a billion-mile thick shell of space around our solar system. And how dense is it? If you picked a random point in the Kuiper Belt, the nearest object of any significant size might be millions of miles away. It's like spreading a handful of sand grains across the entire United States and calling it a belt. Even the Kuiper Belt isn't the edge of our solar system. Beyond it lies the Oort cloud, a theoretical spherical shell of icy objects that extends from about 2,000 AU to 100,000 AU from the Sun. That's nearly 2 light-years away. A light-year, by the way, is the distance light travels in 1 year, about 6 trillion miles. The Oort cloud is so vast and so empty that we've never actually observed it directly. We infer it exists because long-period comets have to come from somewhere. But if you were somehow transported to the Oort cloud, you'd see nothing. Just distant, impossibly faint stars in every direction, including our own Sun, which would look like just another bright star in the sky. The nearest Oort cloud object to you might be tens of millions of miles away. This is the true edge of our solar system, a nearly 2 light-year wide sphere of almost perfect nothingness with occasional tiny ice chunks scattered throughout it. Now we come to the real emptiness, the void between stars, the interstellar medium. Our nearest neighboring star is Proxima Centauri, part of the Alpha Centauri system, sitting about 4.2 light-years away. That's about 25 trillion miles. If you wanted to walk there, it would take you about 900 million years. The fastest spacecraft humans have ever built, the Parker Solar Probe, would take about 7,000 years to get there. Let's use our scale model again. Remember, we shrank the sun down to a golf ball, and our solar system stretched about 2 miles. On that scale, how far away is Proxima Centauri? About 1,000 miles. If our golf ball sun is in New York City, Proxima Centauri is in Jacksonville, Florida. And between those 2 points? Nothing. Not a single planet, not a single asteroid, not a single object larger than a grain of dust. Just vast, empty, cold darkness. But is it truly empty? Not quite. There is something between the stars. We call it the interstellar medium, and it consists of gas and dust spread incredibly thin across space. How thin? In the densest regions of the interstellar medium, you might find about 1 million atoms per cubic centimeter. That sounds like a lot until you realize that Earth's atmosphere at sea level contains about 25 quintillion atoms per cubic centimeter. That's 25 billion. The densest parts of the interstellar medium are 25 trillion times less dense than sea-level air. In fact, the interstellar medium is so thin that if you tried to breathe it, you would suffocate just as quickly as if you were in a perfect vacuum. Your lungs could expand to fill an area the size of a city block and still wouldn't collect enough atoms for a single breath. Most of the interstellar medium is even less dense than that. In typical regions between stars, you might find only 1 atom per cubic centimeter. In the vast voids between spiral arms of galaxies, you might find only 1 atom per cubic meter. That's a volume the size of a large refrigerator containing a single atom. To put it another way, if you took a cube of space, 1 meter on each side in the interstellar medium, and compressed all the matter in it together, you'd have less mass than a single bacterium. The Voyager probes, launched in 1977, are our most distant ambassadors to the cosmos. Voyager 1 is currently about 15 billion miles from Earth, more than 150 times the distance from Earth to the Sun. It's officially in interstellar space, having crossed the boundary where the Sun's influence ends and true interstellar space begins. After traveling for more than 45 years, Voyager 1 has covered less than 0.03% of the distance to Proxima Centauri. It won't reach another star system for about 40,000 years. And during all that time, it will pass through nothing but the sparse, thin interstellar medium. Think about that. Our fastest, most distant probe, traveling at about 38,000 miles per hour, would need 40 millennia to reach our nearest neighbor. That's longer than recorded human history. The entire rise and fall of civilizations, all of human achievement, barely registers against the timescale needed to cross the smallest gap between stars. Let's zoom out further. Our sun is one of somewhere between 100 and 400 billion stars in the Milky Way galaxy. That sounds crowded, right? Hundreds of billions of stars. Surely there's not much empty space at that scale.
And that's the fame to make of happenings. I'm agreed to be within your time. By repast, he has a struggle happening. From me to the earth in terror, John. Look, babe, it's always like you're the break on again, kind of. Mommy, we're really kissing that window. It's a rock.
The Milky Way is about 100,000 light-years across. That's 600 trillion miles. And in that entire vast disk, containing hundreds of billions of stars, the average distance between stars is about 5 light-years. Remember, Proxima Centauri, our nearest neighbor, is 4.2 light-years away. We live in a slightly denser than average region. Let's do the math. The volume of the Milky Way's disk is roughly 800 trillion cubic light-years. With about 200 billion stars, that means each star has, on average, about 4 cubic light-years of space to itself. A cubic light-year is a volume about 56 trillion miles on each side. If you scaled things down so that each star was the size of a grain of sand, the Milky Way would be the size of North America, and those grains of sand would be, on average, about 10 feet apart. Most of the continent would be completely empty. Here's where it gets really interesting. Galaxies collide. In fact, the Milky Way is currently colliding with several smaller galaxies, and in about 4 billion years, it will collide with the Andromeda Galaxy, our nearest large galactic neighbor. When astronomers say galaxies collide, what actually happens? Do stars smash into each other? Do planets explode? Does everything get destroyed? No. Almost nothing happens to individual stars. Remember, galaxies are so empty that when two galaxies merge, the vast majority of stars simply pass by each other without incident. The distance between stars is so huge compared to their size that the probability of two stars actually colliding during a galactic merger is essentially zero. Think about that. Two enormous structures, each containing hundreds of billions of stars, can pass through each other, and almost nothing makes physical contact. It's like two clouds of gnats flying through each other. Individual gnats might get close, but actual collisions would be extraordinarily rare. This realization that the universe is not just dangerous, but ultimately fatal to everything we value, is perhaps the deepest terror that space can inspire. Between the spiral arms of our galaxy lie even vaster voids. The space between spiral arms is where star formation has largely stopped, where the interstellar medium is thinnest, where the darkness is most complete. If you could somehow transport yourself to a point between the spiral arms, far from any star, you'd see a sky with a few dozen faint points of light and otherwise pure blackness. No Milky Way band, no bright stars, just void. Some regions of these inter-arm spaces are dozens or even hundreds of light years from the nearest star. If Earth were located in one of these regions, the night sky would be almost entirely black. The sun would be the only bright object visible, and the nearest star might appear as faint as the dimmest stars we can see from Earth today. Now let's leave our galaxy entirely. The Milky Way is part of the local group, a collection of about 80 galaxies spread across about 10 million light-years. Our nearest large galactic neighbor, Andromeda, is about 2.5 million light-years away. On our earlier scale, where the Sun was a golf ball and Proxima Centauri was 1,000 miles away, the Andromeda Galaxy would be roughly 25 million miles away, about 100 times the distance from Earth to the Moon. And between our golf ball Sun and Andromeda, nearly perfect emptiness, with a few dozen small satellite galaxies scattered throughout. The local group itself is part of the Virgo supercluster, a larger structure containing about 100 galaxy groups and clusters. The Virgo supercluster spans about 110 million light-years, and it's part of an even larger structure called Laniakea, which contains about 100,000 galaxies spread across 520 million light-years. But here's the key thing. These structures, vast as they are separated by even vaster voids. When we map the universe at the largest scales, we see something remarkable. Galaxies aren't randomly distributed. They are arranged in a vast cosmic web of filaments, walls, and clusters, separated by enormous voids. These voids, the gaps between the filaments, are the emptiest places in the universe. They're regions of space anywhere from 100 million to 1 billion light-years across that contain almost no galaxies, not few galaxies, almost none. The Botet's void, one of the largest known voids, is about 330 million light-years across. It contains only about 60 galaxies, compared to the 10,000 or more you'd expect in a region that size based on the average density of the universe. Some supervoids contain essentially zero galaxies, just vast, dark, empty bubbles of space, larger than anything else in existence. If you were somehow transported to the center of one of these voids, you would see nothing. No galaxies, no stars, No light except perhaps one or two extremely faint, distant galaxies billions of light years away. You would be in a bubble of darkness, hundreds of millions of light years across, surrounded by the most complete nothingness that exists in our universe. And those voids, they're growing. The universe is expanding, and more specifically, it's accelerating in its expansion due to something we call dark energy. The voids between galaxy clusters are getting bigger, the distances are getting larger, and the universe is becoming more empty over time. In trillions of years, if dark energy continues to dominate, galaxies outside our local group will be pushed so far away by the expansion of space that their light will no longer reach us. Future civilizations looking up at the sky will see only the galaxies in their local neighborhood. Everything else will have disappeared beyond the cosmic horizon. The universe will appear far smaller, far emptier than it does today. Eventually, even the galaxies in our local group will exhaust their fuel. Stars will die and not be replaced. Black holes will evaporate. And the universe will become a dark, cold, nearly empty void, punctuated by rare, isolated black holes separated by distances so vast that they make current cosmic distances look tiny by comparison. So we've measured the void. We've quantified the emptiness. But what have we learned? First, let's address the obvious question. Is space truly empty? We've seen that the interstellar medium contains atoms, even if only one per cubic meter. Quantum field theory tells us that even empty space isn't truly empty. It's filled with quantum fields that can create virtual particles popping in and out of existence. Space itself is something it can expand, it can curve, it has properties. So in a philosophical sense, perfect nothingness doesn't exist in our universe. There's always something, quantum fields, the fabric of space-time itself, dark energy, the occasional stray atom. But in a practical sense, the universe is overwhelmingly empty. If you randomly selected a point in the universe, the chances of it being anywhere near matter would be essentially zero. You'd almost certainly be in intergalactic space, in a region between galaxy clusters, where the nearest atom might be meters away, and the nearest star might be millions of light years away. Here's a staggering fact. If you added up all the matter in the universe, every star, every planet, every atom in every galaxy, and spread it evenly throughout all of space, you'd have about 5 atoms per cubic meter. 5 atoms in a volume the size of a large refrigerator. That's the average density of the universe. And remember, that's just the ordinary matter. Dark matter, which we can't see but know exists through its gravitational effects, is about 5 times more abundant. But even counting dark matter, the universe is about 30% matter visible and dark and 70% dark energy. And all of that matter is concentrated into tiny, rare clumps called galaxies, with vast voids in between. Matter is the exception, not the rule. Emptiness is the default state of the cosmos. This brings us to something profound, the loneliness of existence. Earth is a tiny speck orbiting a medium-sized star in an unremarkable region of an average galaxy, surrounded by vast distances that humans may never cross. The distance to our nearest star is so vast that, with current technology, it would take longer to reach than civilization has existed. The distance to the nearest large galaxy is so vast that even light, traveling at the ultimate cosmic speed limit, takes 2.5 million years to cross it. If there is other intelligent life in the universe, and statistically, there probably is, the distances between civilizations are likely so vast that communication, let alone travel, might be functionally impossible. The universe hasn't just separated us with distance, it's separated us with timescales. By the time a message travels from one civilization to another, millions of years might pass. Civilizations could rise and fall in the time it takes for a simple hello to arrive. These vast distances also reveal something about the fragility of life. In all that emptiness, in all those trillions upon trillions of cubic light-years of void, we know of only one place where life exists: Earth. Maybe we'll find microbial life on Mars or Europa or Enceladus. Maybe there are millions of inhabited worlds scattered throughout the galaxies. But even if there are, they're separated by such vast gulfs of nothingness that each one is effectively alone. Each living world is an island of complexity and activity in an ocean of emptiness. Life, consciousness, intelligence, these aren't just rare, they're isolated, separated by distances that make interaction nearly impossible. And that isolation is enforced by the universe's speed limit. The speed of light. Nothing can travel faster than light, which moves at about 186,000 miles per second. That's fast-paced enough to circle Earth 7.5 times in 1 second. But against cosmic distances, even light seems slow. Light from the Sun takes 8 minutes to reach Earth. Light from Proxima Centauri takes 4.2 years. Light from Andromeda takes 2.5 million years. Light from the most distant galaxies we can see has been traveling for over 13 billion years, most of the age of the universe itself. The speed of light doesn't just limit how fast we can travel. It limits how fast information can travel. It creates a fundamental isolation between distant parts of the universe. When you look at a distant galaxy, you're not seeing it as it is now. You're seeing it as it was when that light began its journey. The galaxy might not even exist anymore. It could have been torn apart by collisions or swallowed by a black hole. You wouldn't know for millions or billions of years. In fact, there are parts of the universe we can never see. The observable universe, the part from which light has had time to reach us, is about 93 billion light-years across. But the universe itself is almost certainly much, much larger, possibly infinite. There are galaxies beyond our cosmic horizon that we will never see, not because they're too faint, but because the universe expanded too quickly while their light was traveling. Their light will never reach us, and due to the accelerating expansion, there are galaxies we can see now whose light will never reach us again. They're crossing the cosmic horizon right now, disappearing from our universe forever. Each day, more of the cosmos becomes permanently inaccessible to us. The universe isn't just vast and empty. Parts of it are literally beyond our reach, separated by an uncrossable boundary of expanding space. Astronauts who've seen Earth from space often describe something called the overview effect, the cognitive shift in awareness that comes from seeing the planet as a small, fragile ball floating in blackness. The emptiness of space, directly witnessed, changes people. Edgar Mitchell and Clamapelson Astjabit, frightening Rustinat, described it like this. You develop an instant global consciousness, a people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. Seeing the emptiness makes you realize how rare and precious the not emptiness is. All of human history, every war, every love story, every scientific discovery, every piece of art, every laugh and tear has happened on that tiny blue dot surrounded by incomprehensible emptiness. Our squabbles seem petty. Our borders seem arbitrary. Our differences seem trivial when viewed against the backdrop of the cosmic void. There's a concept in cosmology called the mediocrity principle, which suggests that Earth, humanity, and our circumstances are probably not special. We're likely typical, average, mediocre in the cosmic scheme of things. If that's true, then other civilizations probably face the same isolation we do. They're probably also surrounded by vast emptiness, also staring at distant lights in their sky, also wondering if they're alone, also realizing that the distances are too great and the universe too empty for easy contact. In a sense, the emptiness unites us with whatever other intelligent life might exist. We're all lonely together, separated by voids we can measure but not cross, aware of each other's probable existence but unable to reach each other across the gulf. So why is the universe so empty? Why is there so much nothing compared to something? The answer lies in the very beginning. In the first fraction of a second after the Big Bang, the universe underwent a period of exponential expansion called inflation. Space itself expanded faster than light, stretching a tiny, dense region into the vast cosmos we see today. That rapid expansion spread matter incredibly thin. And because the universe has been expanding ever since, it's become even more spread out, even emptier, over the past 13.8 billion years. In a sense, the universe is empty because it grew too fast. It expanded from something smaller than an atom to something vast beyond comprehension in a fraction of a second, and it's been getting bigger and emptier ever since. But here's an interesting twist. The universe had to be this empty for us to exist. If the universe were much denser, gravity would have pulled everything back together into a big crunch long ago. Stars wouldn't have had time to form, let alone evolve life. If the universe were much less dense, matter would be so spread out that stars and galaxies never would have formed at all. The universe would be uniformly thin, cold, and dark. The amount of emptiness in our universe is just right. Not too much, not too little, to allow structures like galaxies, stars, and planets to form and persist for billions of years. The void is necessary for existence. So what do we do with this knowledge? How do we live knowing we're surrounded by such vast, empty nothingness? Some find it terrifying, existentially horrifying to contemplate the endless void, the cosmic loneliness, the ultimate insignificance of our tiny speck of existence. Carl Sagan called space a vast and awesome arena. And there's something humbling, even frightening, about recognizing our place in it. But others find it beautiful. The emptiness makes matter precious. The distances make life rare and special. The void gives meaning to the not void. As Sagan also said, the cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. We are the universe's way of looking back at itself, of measuring the void, of appreciating the incredible unlikeliness of existence. We are patterns of matter and energy complex enough to contemplate the emptiness from which we arose and to which we'll return. The true scale of nothingness isn't just about the vast distances between stars or the empty voids between galaxies. It's about recognizing what those distances mean. It's about understanding that existence is rare, that connection is precious, that the matter and energy that formed into you is something special against the backdrop of cosmic emptiness. Every atom in your body was forged in the heart of a dying star. Those atoms traveled through the emptiness of space, were gathered by gravity into our solar system, assembled into a planet, and eventually became part of you. You are stardust, temporarily arranged in a way that can wonder about the void from which you came. So the next time you look up at the night sky, remember those stars you see aren't what's important. It's the black spaces between them. That darkness represents the true nature of the universe, vast, empty, and ancient. But here, on this tiny world, for this brief moment in cosmic time, there's something rather than nothing. There's life, consciousness, wonder, and the ability to measure the immeasurable. The universe is almost entirely empty, but we're here anyway, in defiance of that emptiness, complex patterns of matter, contemplating the void. And that, perhaps, is the most remarkable thing of all.